The James Webb Space Telescope has just achieved a historic milestone by capturing the first ever real and authentic image of Oumuamua. Although this enigmatic interstellar object was first discovered by scientists in 2017, there were a lot of doubts about whether the picture obtained at that time was enough to tell us everything we ought to know about this strange visitor. But now, a significant breakthrough has offered new insights with an exclusive image captured by JWST. How relevant is this discovery to scientists, and what new details does it reveal? Join us as we look into the terrifying objects in space that the James Webb Telescope revealed. Oumuamua is the first confirmed object from another star to visit our solar system. This interstellar visitor looks like a rocky, cigar-shaped object with a reddish tint. The discoverers named it Oumuamua, which means a messenger from afar arriving first, in Hawaiian. Oumuamua is up to 1/4 mile, 400 meters, long and very elongated, about 10 times longer than it is wide. This aspect ratio is greater than any asteroid or comet observed in our solar system so far. While its stretched-out shape is surprising and different from objects in our solar system, it could offer new insights into how other solar systems formed. The observations suggest that this unusual object has been drifting through the Milky Way, not bound to any star system, for hundreds of millions of years before its unexpected encounter with our solar system. But how exactly was Oumuamua found? Stay tuned because the most shocking part is yet to come. On October 19, 2017, a strange object named Oumuamua was detected speeding through our solar system. This asteroid had been traveling for over a century before it was finally identified. It reached a significant cosmic milestone in 1837, but astronomers missed it. Oumuamua would continue its journey through our solar system for several decades at a steady speed, and astronomers and telescopes failed to detect it. It wasn't until 2017 that Robert Werrick, a scientist at the University of Hawaii, noticed a faint, elongated streak in the sky captured by the Pan-STARRS 1 telescope, revealing a fast-moving object unlike any seen before. Initially, scientists thought Oumuamua was a comet because of its unusual behavior, but they later identified it as an asteroid, a small rocky object usually found in the asteroid belt between Mars and Jupiter. However, further observations showed that Oumuamua was moving away from the Sun at an unusual rate, deepening the mystery. The lack of visible outgassing, which typically occurs in comets, puzzled scientists as the object accelerated in a way that defied predictions, leading them to question whether it was truly an asteroid or comet. One of the most remarkable features of Oumuamua was its consistent brightening and dimming every 7.3 hours, indicating that it was tumbling and most likely spinning around its shorter axis. Such speed suggested that Oumuamua was a solid object with a stronger and more durable composition than most comets, which are typically loose and fragile. Its dark red color, similar to that of moons in the outer solar system, showed that it had been exposed to cosmic radiation for millions of years, altering its surface. As experts analyzed the data, suspicions about the true nature of Oumuamua began to surface. Some speculated that it might be an advanced extraterrestrial probe or a defunct alien spacecraft, while others considered more likely possibilities, such as a previously unknown type of comet or asteroid. Even more conservative theories suggest that Oumuamua is a remnant of an exoplanet that was ejected during a catastrophic event in another star system. There is still no consensus on what Oumuamua actually is. Predicting Oumuamua's future path has proven difficult because it has already started to move away from the Sun, exiting our solar system at a sharp angle. Current estimates suggest that Oumuamua is returning to interstellar space, where it will continue its lonely journey across the universe. The discovery of Oumuamua sparked intense debate and interest among astronomers, scientists, and the general public. This unusual cosmic object, the first of its kind ever found, inspired a flood of theories trying to explain its origins and nature. Was it just a regular cosmic object, or could it have been an alien probe sent to explore our solar system? Let's look deeper into the various theories and evidence that have emerged in the effort to understand the mystery of Oumuamua. Because of the various data that was gathered, theories concerning Oumuamua evolved. Some experts suggested that Oumuamua might be filled with gas, which could explain its sudden acceleration as it moved away from the Sun. Then came the shocking suggestion that it might not be a natural object at all, but rather an alien spacecraft. The unusual properties of Oumuamua, particularly its non-gravitational acceleration, support this idea. Typically, comets accelerate due to outgassing, the release of gas and dust as they approach the Sun and heat up, but no such outgassing was observed with Oumuamua. Therefore, some researchers began to consider more unconventional ideas. Could this be a probe sent by an extraterrestrial civilization to investigate Earth? Although this sounds like science fiction, for those who believe in the possibility of extraterrestrial life, it is one of the most fascinating ideas. Dr. Michio Kaku, a well-known theoretical physicist, suggested that Oumuamua was ejected from a distant star during a supernova explosion. According to billionaire entrepreneur Elon Musk, the object might have formed when two celestial bodies collided and melted, resulting in its unique hybrid shape. Initially, astronomers were excited to find that Oumuamua's trajectory appeared to be aligned with Vega, the brightest star in the Lyra constellation, known for its debris disk. Calculations suggested that Oumuamua might have taken about 600,000 years to reach its current position from Vega. However, this theory quickly fell apart when it became clear that Oumuamua's path had changed during its journey. Astronomers concluded that it must have passed close to a new star system before entering our solar system. Its speed was similar to that of nearby stars, increasing the likelihood that Oumuamua had been traveling through the Milky Way for billions of years before crossing paths with our solar system. Another interesting theory suggests that Oumuamua is a piece of nitrogen ice. Researchers Alan Jackson and Stephen Desch of Arizona State University proposed that it could be debris blown off a Pluto-like object by a massive impact. For this theory to hold, Oumuamua would have to be much smaller than previously thought. Despite this, the nitrogen ice theory has gained traction since it can explain both the object's composition and its unusual acceleration. One of the most significant discoveries made shortly after Oumuamua's detection was that it was traveling in a hyperbolic orbit, a boomerang-shaped trajectory that strongly indicated it was not native to our solar system. Instead, it was just passing through and would never return. This revelation led to speculation about its future visibility, with many believing that Oumuamua would disappear into space, never to be seen again. But Oumuamua would defy all odds and prove most theories wrong. However, the object's behavior defied expectations. One particularly notable feature was its unexpected increase in speed as it approached the Sun. While gravitational forces from large celestial bodies like planets and stars can speed up smaller objects such as comets and asteroids, they couldn't fully explain Oumuamua's acceleration. The object's speed reached 54 miles per second, 87 kilometers per second, about 3 times that of the average comet in our solar system. This anomaly prompted experts to reconsider their initial classification of the object as an asteroid, leading many to speculate that it might actually be a comet. Recently, Jennifer Doudna, a chemistry professor at the University of California, Berkeley, and Darrell Seligman, a postdoctoral fellow at Cornell University, suggested a new explanation. They proposed that Oumuamua's acceleration could be due to outgassing driven by unfamiliar processes occurring outside our solar system. According to their theory, while Oumuamua traveled through interstellar space, it was exposed to cosmic radiation. This radiation might have released stored hydrogen trapped in the object's icy structure. When Oumuamua entered the solar system and warmed up, this hydrogen could have been released, providing the force needed to explain its acceleration. Their calculations indicated that the outgassing of hydrogen might account for Oumuamua's movement. Decades of experiments support their idea that high-energy cosmic rays can break hydrogen molecules from water ice, storing it within an object. Seligman claimed this explanation is simpler and more plausible than previous, more speculative theories, such as Oumuamua being made of hydrogen ice or some exotic material. However, not all scientists agree. Harvard scientist A.V. Ilub, who had previously suggested that Oumuamua might be an alien spacecraft, disagreed with Doudna and Seligman's theory. Loeb argued that they overestimated the amount of hydrogen Oumuamua could contain due to an error in their temperature calculations. According to Loeb, there wouldn't have been enough hydrogen to cause the observed acceleration, leaving the mystery unresolved. With Oumuamua now out of reach, we may never know its true nature or chemical composition. Seligman remains hopeful that more interstellar objects will be discovered soon, giving astronomers more chances to study these visitors. The next generation of telescopes, expected to be operational within the next decade, could greatly advance this research and help answer questions about interstellar objects. As scientists debated Oumuamua's origins and behavior, they encountered a new surprise: the possibility that Oumuamua isn't alone. Recent findings suggest it might have a companion interstellar object. This discovery raises new questions. What could this companion be, and did it play a role in Oumuamua's strange journey to our solar system? Could it signal a new era in our understanding of cosmic events, or does it hint at something more ominous? Some scientists have proposed sending robotic probes equipped with sails to intercept and study Oumuamua more closely. However, current technology isn't advanced enough for such a mission, though projects like Breakthrough Starshot are exploring the idea of sail-driven spacecraft capable of reaching distant stars. While catching up with Oumuamua is impossible for now, its brief visit has provided valuable insights for future encounters with similar objects. Though it may have taken billions of years for Oumuamua to reach its current position, its passage through our solar system was a fleeting moment on a cosmic scale. Given the Milky Way galaxy's estimated 10 billion-year age, Oumuamua could have traveled through up to 20,000 different star systems on its journey. Though this number is only a tiny fraction of the estimated 200 billion stars in the galaxy, it suggests that Oumuamua has had many cosmic interactions, possibly collecting dust and debris from various environments along the way. Some researchers, including Elon Musk, who has loads of interest in space matters, have speculated that Oumuamua might be heading toward the Kuiper Belt, a region of frozen objects beyond Neptune. Tracking its exact position has been challenging, and scientists rely on mathematical models and limited observations to project its course and potential destinations. Despite predictions, no one has pinpointed its exact location or confirmed its future path. One of the most perplexing features of Oumuamua's movement is its unusual acceleration. While its speed indicated that other forces were at work, most celestial objects are primarily influenced by gravitational forces. Astronomer Dr. Michelle Bannister proposed several possible reasons for Oumuamua's unusual acceleration. One theory suggests that Oumuamua might be experiencing outgassing, a process common in comets where ice sublimates directly into gas, which can push the object forward, changing its speed and rotation as it approaches the Sun. This theory aligns with the behavior of known comets, where dust is carried away by gas escaping from the surface. However, as earlier said, Oumuamua did not show any obvious signs of outgassing at any point. Dr. Bannister suggested that the object might still have particles that are affecting its velocity. Adding to the mystery, astronomers struggle to detect the usual signs of outgassing, such as cyanogen, CN, gas, which is often found in comets. Despite thorough searches, no gas emissions were detected. This suggests that Oumuamua could be chemically unique compared to any comet in our solar system. In an attempt to gather more information about the object's composition, researchers tracked it for over 30 hours using the Spitzer Space Telescope. Yet, their efforts yielded no clear answers. The lack of thermal emissions and obvious gas made it even harder to classify Oumuamua. Some scientists suggested that Oumuamua might be more reflective than initially thought if it showed thermal characteristics similar to those of a comet, but these details remain unclear. An object's reflectivity, or albedo, can provide clues about its size, composition, and surface features. Although much has been learned about Oumuamua, no one has definitively identified what it is. It remains a unique and mysterious interstellar visitor that challenges our understanding of celestial objects and raises more questions than answers. Some have wondered if Oumuamua might be something more extraordinary or even a potential threat, given its erratic movement and the lack of hard data. Although some speculative theories recently suggested it could be on a collision course with Earth in the coming weeks, most data refutes these predictions. About 6 months before Oumuamua's close encounter with Earth, a small interstellar meteor, about 3 feet, 1 meter, in size, crashed onto our planet. Although it had no clear connection to Oumuamua, AVI Lab took an interest in this meteor, known as IM2. Lab speculated that an artificial interstellar object could act as a parent craft, releasing several small probes as it passed near Earth. In a draft research paper, Lab and Sean Kirkpatrick, director of the Pentagon's All-Domain Anomaly Resolution Office, AARO, explored this idea, which ties into the government's term for UFOs, unidentified anomalous phenomena, UAP. Their theory suggests that these probes could be expelled from a larger vessel by natural forces, such as solar radiation or gravitational pressures from the Sun. Due to their small size and limited reflection of sunlight, these dandelion seed probes, as Webb called them, might go unnoticed by our telescopes. These tiny probes could then approach Earth's atmosphere using specialized technology that allows them to slow down and avoid burning up, possibly even landing safely using parachute-like structures. Webb's hypotheses focus on the possibility that extraterrestrial civilizations might be interested in studying rocky planets with atmospheres, such as Earth, Mars, and Venus. Such planets would naturally attract the curiosity of intelligent life forms, who might have launched exploratory probes long before humans began exploring space. In this scenario, the probes might not be in constant communication with the mothership, and could have become lost or inactive over time. Webb likened this idea to checking a mailbox for letters from someone who may no longer be alive, suggesting that the probes could continue their mission even if the civilization that created them no longer exists. Webb has faced significant skepticism from the scientific community since he first suggested in 2018 that Oumuamua could be an alien spacecraft. Many researchers argue that his idea is purely theoretical and lacks strong evidence. In 2021, a letter published in the journal Astronomy and Astrophysics dismissed the possibility of interstellar travel, citing the immense cosmic time scales required to travel between stars. The letter's authors concluded that Oumuamua was more likely a naturally occurring object, possibly an oddly shaped rock, rather than an intentional probe sent by an alien civilization. Other studies have supported this natural explanation, pointing to hydrogen outgassing as the most likely cause of Oumuamua's unusual acceleration. Researchers published findings on March 22, 2023, indicating that as Oumuamua passed through the inner solar system, it likely released hydrogen trapped within its frozen body, mimicking propulsion from an unidentified source. Despite these explanations, the Pentagon has intensified its investigation into unexplained aerial phenomena within U.S. airspace. Since its establishment, the All-Domain Anomaly Resolution Office has initiated over 360 new investigations into reported encounters with unidentified objects involving U.S. military personnel. About half of these cases have been linked to balloons or other objects, while the other half remain unresolved due to insufficient data. To solve the mysteries of interstellar space and investigate objects like Oumuamua, humanity needs to gain a deeper understanding of dark energy and other cosmic phenomena. The idea of sending a spacecraft to chase after this mysterious object is exciting, but it presents significant challenges. For example, Oumuamua, which is moving at incredible speeds, will pass beyond Saturn's orbit in just 2 years. With a hyperbolic excess velocity of $5.50 per year, the mission to pursue Oumuamua is unlike anything humanity has ever attempted. Even our fastest spacecraft cannot match these speeds. So, what kind of vessel could carry out such a mission? Should we rely on advanced technologies like solar sails, or should we explore more speculative propulsion techniques, such as wormholes? As we consider these technological challenges, it's important to recognize that humans are unique among Earth species in their desire to explore space. Most animals on Earth, from birds to reptiles to fish, have no concern for what lies beyond their immediate surroundings. Even among sentient species like whales, the idea of space exploration or communication with extraterrestrial beings is entirely foreign. This raises an interesting question. If Earth's intelligent species largely ignore space, what does this imply about potential extraterrestrial civilizations? Could they be oblivious to the larger cosmos, much like most creatures on Earth? The Fermi paradox. Given the universe's 14 billion-year history and the fact that humans have only had the technology capable of detecting alien signals for just over a century, it's conceivable that we're only scratching the surface of what's out there. For all the radio waves, messages, and other communications we've launched into space, the vastness of the universe makes them akin to throwing a grain of sand toward the peak of a mountain, hoping it might hit a bird perched at the summit. Despite this, scientists remain hopeful that extraterrestrial civilizations exist, leading to the development of the Fermi paradox. The Fermi paradox highlights the conflict between the high probability of extraterrestrial civilizations existing and our complete lack of evidence for them. With over 400 billion stars in our galaxy, many of which are expected to have habitable planets, it's reasonable to expect intelligent life to arise elsewhere and develop interstellar travel technologies. Given that many stars are billions of years older than our Sun, these civilizations should be far ahead of us. However, we have found no strong evidence of their existence. The Fermi paradox states that extraterrestrials should exist and be capable of interstellar travel, but we have had no clear contact with them. This seeming paradox has led some to suggest that our search efforts are futile and that resources should be redirected elsewhere. Critics argue that unless extraterrestrials make themselves known, there is little reason to continue funding research like SETI, Search for Extraterrestrial Intelligence. The paradox is named after physicist Enrico Fermi, who launched this line of inquiry with his famous question, "Where is everybody?" during a casual conversation with other scientists. His question has often been misunderstood as meaning, if extraterrestrials exist, why aren't they here? Despite technological advancements and an increased understanding of the universe, we still don't have a satisfactory answer. Although scientists have refined estimates of numerous cosmic quantities, such as the number of galaxies, stars, and potentially habitable planets, we are still confronted with vast unknowns. For example, while we can hypothesize about the likelihood of life forming on an Earth-like planet or evolving into an intelligent, communicative species, there is little scientific data to support these predictions. The presence of life on Earth does not mean that it will naturally occur elsewhere. With only one sample size, Earth, drawing broad conclusions about the likelihood of life in the universe is speculative at best. Many scientists have sought to solve the Fermi paradox, yet the solutions vary from mundane to extraordinary. Some argue that sentient civilizations are either too far apart or lack the technology to communicate over such long distances. Others suggest that advanced civilizations may actively choose to remain silent, either to avoid detection or because they lack interest in exploring the universe. The dark forest theory, which proposes that intelligent civilizations may remain hidden out of fear, is particularly unsettling. In a universe with limited resources and intense competition, revealing one's presence could lead to destruction. This theory suggests that the universe is like a dark forest, with each civilization acting as a silent hunter, avoiding notice to ensure survival. The frightening implication is that any civilization that announces its existence risks being annihilated by a more advanced and hostile race. The dark forest theory also assumes that alien life would think similarly to humans, focusing on self-preservation and competition. However, this assumption could be flawed. Alien intelligence could be so fundamentally different from ours that we don't understand its goals, behaviors, or methods. They may not think in terms of exploration, conquest, or communication, making our efforts to detect them futile. Another hypothesis is that humanity is one of the most advanced civilizations in the galaxy. If other civilizations are less technologically developed, they may not be able to send messages or build spacecraft. For example, if an alien species is only a century behind us, they will have only been transmitting signals for a few decades, which is not enough time for the signals to reach Earth. This scenario suggests that our current search methods may produce false negatives, as we are looking for signs of civilizations that do not yet exist or have only recently developed the necessary capabilities. The idea that we are alone in the universe seems increasingly unlikely. However, proving otherwise is equally challenging. Perhaps there are civilizations so advanced that they view humanity as entertainment, much like we watch wildlife documentaries. Alternatively, they may be so alien in their thinking that they have no desire to approach us. When considering these possibilities, it's important to remember that the Fermi paradox and programs like SETI often assume that extraterrestrial civilizations are more advanced than ours. But what if that assumption is wrong? What if most civilizations have similar or lower technology levels? In this case, their attempts at communication may be too primitive for us to detect. In 2019, Gennady Borisov, an amateur astronomer at the Margot Observatory in Crimea, discovered a new comet and named it 2I Borisov. This comet, traveling through space at an astonishing speed of 93,000 miles per hour, 150,000 kilometers per hour, immediately captured the attention of experts worldwide. Such a velocity, especially given its distance from the Sun, was significantly higher than what is typically observed for objects in our solar system. However, researchers were intrigued not just by the comet's speed but also by its unusual trajectory. 2I Borisov's orbit had an exceptionally high eccentricity of 3.7, plunging into the inner solar system at a steep 40-degree inclination relative to the ecliptic. This indicated that, like Oumuamua, 2.8 came from outside our solar system, making it the second confirmed interstellar object ever discovered. Unlike Oumuamua, whose nature is still debated, 2.8 was easily identified as a comet. It had the typical characteristics of a comet, including a visible tail, which made it straightforward to classify. The comet approached the Sun and came closest to Earth on December 28, 2019, at a distance of about 2 astronomical units, AU. As it neared, it brightened before gradually dimming and eventually disappeared from amateur astronomers' view by October 2020. During this time, Dr. Michelle Bannister's team conducted extensive observations of 2.8. They estimated its diameter to be between 1.2 and 10 miles, 2 to 16 kilometers. Furthermore, scientists detected the emission of cyanogen, CN, gas from the comet's surface, a common feature of comets. However, due to the comet's faintness, detecting other gases proved challenging. The enhanced visibility of 2.8 made it particularly valuable for studying its composition and behavior. This provided a rare opportunity for scientists to investigate the chemistry of an object that originated outside our solar system. Two distinguishing features of 2.8 stood out: its typical comet-like appearance and its reddish hue, which is consistent with many comets observed in our solar system. These observations highlighted the diversity of interstellar objects, offering insights into the processes that shape other star systems and broadening our understanding of the universe. As scientists studied interstellar visitors such as Oumuamua and 2.8, theories about extraterrestrial origins gained traction. Notably, some astronomers speculated that Oumuamua could have been an alien probe, a view supported by figures like Harvard professor A.V.I. Lubb. Adding to the excitement, in 2022, the Pentagon's All-Domain Anomaly Resolution Office, AARO, was established to investigate mysterious objects, with its director, Sean Kirkpatrick, even speculating about the possibility of an extraterrestrial mothership within our solar system. This hypothetical mothership might release microscopic probes, like dandelion seeds, to study planets such as Earth. Among the most fascinating phenomena in the cosmos are black holes. Black holes are thought to form when massive stars collapse under their gravity. They are known for their incredibly strong gravitational pull, which prevents even light from escaping. Millions of black holes are believed to exist throughout the universe. Our Milky Way galaxy alone is estimated to contain around 100 million black holes. Black holes have long been regarded as distant objects, hidden far from our immediate cosmic neighborhood. Despite their ominous reputation in popular culture, including movies like Interstellar, this view has recently changed. In relatively recent cosmic terms, a team of scientists reported the discovery of a black hole just 1,600 light-years from Earth. A light-year is approximately 9.4 trillion kilometers, the distance light travels in 1 year. Gaia BH1, a newly discovered black hole, was identified using data from the European Space Agency's Gaia spacecraft. This black hole is notable for being the closest known to Earth, located about 1,600 light-years away in the constellation Ophiuchus. To put this in perspective, Gaia BH1 is 3 times closer to us than any other black hole ever found. It has a mass roughly 10 times that of our Sun, making it a significant object of study for astronomers. The discovery of Gaia BH1 was made possible by observing a star that is in orbit around the black hole. This method of detection is crucial because black holes themselves do not emit light, making them incredibly difficult to spot directly. Instead, scientists look for the effects of a black hole's gravity on nearby stars and other objects. The Gaia spacecraft has played a vital role in this discovery. With its ability to track and analyze over 800,000 multi-star systems, Gaia has proven to be an incredibly reliable tool for uncovering new cosmic phenomena, such as this nearby black hole. This discovery brings us closer to understanding the mysterious nature of black holes in our galaxy. What exactly are your thoughts on the discovery of Oumuamua? If you enjoyed watching this video, make sure to like, share, and subscribe to our YouTube channel for more. Also, click on the next video shown on your screen. You will enjoy it.